Hello students. So today we are gonna discuss questions on thermodynamics. So let's see the first question here. That is, two reactions are given below. Okay, one is from CO plus half O2 gives CO2, and one is Ag2O to two silver and half mole of oxygen is exited. So they have given us four options and told us which of them is true or correct. Okay, so let's see. We have to know its del ng first. So let's see what will be its del ng. That is, its del ng will be mole of product, that is 1 minus half minus 1. That means its del ng is minus half, that is less than 0, right? So its del h will be less than del E, that we have seen in our thermodynamics video, that why this del h is less than del E. So let's see for the next question. That is, del ng will be, here it is half plus 0 minus 0. Why it is 0? Because 2 Ag is solid and Ag2O is also solid. So their mole can be taken here, because it is only del ng is only valid for gas. Okay, so it will be plus, so its value is greater than 0, del ng is value, so here del h will be greater than del E. So in which of the these options it is correct? That is for this option 1. So we are going to mark it. Okay, so here our first question is done. Now let's see the second question. That is, they have given us 200 joules of heat and to supply to system in a constant volume. Okay, now you have to see this condition that is given to us, that is at constant volume. It resulted in the increase in the temperature of the system from 298 Kelvin to 233 Kelvin. What is the change in the internal energy? Okay, so let's see it. That is, its answer will be, we know that del U equal to Q plus W from our first law of thermodynamics, but they said that at constant volume, so means del V equal to 0. So here our work done will be 0. So whatever the value comes, that will be equal to Q, right? And Q is given here, that is 200 joules, right? So we are just gonna write it 200 joules. So that will be our answer for the change in the internal energy. Now for the third question, they have given us reaction of methanol with dioxygen was carried out, and del U is found to be 726 kilojoule per mole at 298 Kelvin. So the change in the enthalpy will be, so let's see what will be its answer. That we know this formula, del H equal to del U plus del ng RT, right? Now to apply this formula, we have to write its reaction equation first. So let's write it. That is CH3OH. Okay, that will be a liquid, plus 3/2O2, that will be our gas. You have to write it yourself in the examination. Okay, CO2, that is our gas, plus 2H2O, that is our liquid. So here let's apply the del ng here. That will be 1 minus 3/2 So del Ng will be minus half. So let's just put the values given to here. What will be that is it's given kilojoules. So we're gonna write it like this. Okay, we're gonna write it like this, minus half into value of R is 8.314 joule per Kelvin per mole, and our T will be 298. Okay, so what will be the value? The value, if we calculate it here, that will be 727 to 38.78 joule per mole, right? So the third question is done. So let's see the fourth question. So here they has given us two equations, that is S plus 3 by 2 O2 equal to SO3 plus 2x kilocalorie, and here SO2 plus half O2 equal to SO3 plus y kilocalorie. So the heat of formation. So you have to know the formation equation of the SO2 plus. So that is S plus O2 equal to SO2, right? So if we just write it here in two equations like this, SO3 plus 2x, and here also SO2 plus half O2 SO3 plus y. So what happens? This minus, this is also minus, this is also minus, this is also minus. We just do it here. That is SO3 will be cut, right? And it will be S plus O2, and SO2 will be go here, and it will come plus 2x minus y, right? So heat of formation will be our answer 2x minus y kilocalorie. Okay, so our fourth question is also done. So let's see the fifth question, that is which of the following reactions will have the value of enthalpy of neutralization minus 57.1 kilojoule per mole. So I have told you that this value is called del H neutralization, and it comes minus 57.1 kilojoule for strong acid plus strong base reaction. Okay, only for this criteria, that both of them will be strong, then this value comes minus 57.1 kilojoule per mole. So we have to find out in this question that which of them will be strong acid and strong base. So here we can see in the first option it is our weak acid. Okay, but it is strong base, so it is weak acid, it can be taken. So for the third case, you can see it is strong acid, but NH4 is weak base, so it can also be taken. But HCOOH is our weak acid, NOH is strong base, so it also can be taken. But in case of the second option, if we take it, it is strong acid and it is strong base. So our option 2 is correct, that is value of neutralization will come minus 57.1 kilojoule per mole. Then comes our this question number 6, CH2Cl2 gives us C plus 2H plus Cl. What will be the del H of the reaction? Okay, if the bond energy of CH and CCl are this respectively. So let's do it. That we know if our bond energy is given here, so we just have to put the values and nothing more. So let's do it here only. you can see that the values of the CH and Cl are given. So let's just write them and the value will come itself, right? So let's just write the formula first, that is summation of bond energy of reactants minus summation of bond energy of products. So that will be 2 into B of CH, right? Because here CH2 is given, plus 2 into BE of CCl. Now why did we write this? Because if we write the structure of CH2Cl2 here, so it will be kind of like this, right? Right or wrong? So you can see why did we write it, the 2 bonds of CH and 2 bonds of CHCl. So that's why we written it like that. So let's just put the values here and the answer will come out. That is 2 into 416 plus 2 into 325. That will be our 1482 kilojoule, right? So let's see the seventh question. Sixth question is done. So here we can see a figure is given and they have told us to conclude the del H solution here. So let's see that here we can see that from xy, if del H solution is x plus y minus aqueous, but it is also x lattice plus x del H lattice plus del H hydration here. So from Hess's law, we can write it like this, that del H solution equal to del H lattice plus del H hydration. Now why is this? Because we know what is the resultant del H according to Hess's law, that is it is H1. If we take it is H2, that will be H1 plus H2. That's what we have written here, del H solution equal to del H lattice plus del H hydration. So our question number 7 is done. So let's see question number 8. That is, they have given us a table and told us to match the columns, right? So we have to match the columns. Now first see what is the first option here, that is CH4 plus 2O2 and CO2 plus 2H2O. So you can see that here combustion of CH4 is happening because it is reacting with O2, so it will be our matched with this, right? So let's just write it first. That is A is matched with column through option 3, and then we see that H2 gas is breaking and it into atoms, that is 2H. So let's see if there is any bond dissociation enthalpy here. So that is option number 4 here. So B is option number 4. So let's write it, B option number 4. Then NaCl will be Na plus Cl minus. So it is forming what from solid to gas and gas. So from solid to gas and gas is happening, so that will be our del H lattice. So it goes here. So option number C comes our option 2. So the last one will be NaCl, that is Na plus aqueous, Cl minus aqueous. So it is forming solution. So we are just gonna put it, that is 1. So D comes our 1. So column 1 is matched with column 2. So question number 8 is done. So let's see question number 9. Now in question number 9, they said 50 ml of 1 molar NaOH is mixed with 50 ml of 1 molar HCl, and the temperature is case no T1 is noted, and in second case 100 molar ml of 1 molar NaOH is mixed with 100 ml of 1 molar HCl. So now what we have to do here, that is we have to make a ratio here, NaVa by NbVb 1. Okay, and for the second case also we have to know the ratio, that is NaVa equal to NbVb. So what is Na and what is V? N is normality and V is volume. So let's just see what the ratio comes here. We're gonna write its normality. So normality is molarity into n factor. So HCl's molarity is 1 given here. So its n factor is also 1. So just into volume 50. So for the NaOH, its molarity is also 1 given, and its n factor is 1, and its volume is also 50 given. That means it comes 1. And now for the second case, what happens, that for NaVa comes right, that is 100 into 1 into 1, and for say base also it comes 100 into 1 into 1. So both in the first case and second case the ratio comes 1 1. So its temperature will also be same, that is T1 equal to T2. So let's see in which option that is. That is our first option. So in question number 9, first option will be correct. So here the heat of combustion is given for the 10th question here, and they told you the heat of formation of CS2. Now to do this question we have to first know two things, that is what is the heat of formation formula, that is summation of del H of products minus summation of del H of reactants. Okay, and for here we have to know the equation also, that is C plus 2S, that is comes our CS2, right? So if we just put the values here, that is minus 1108.76 minus of that will be not minus, because minus minus will be plus, so 393.3 kilojoule. Okay, and also plus 2 into here 293.7 kilojoule. So we just have put the value here, that is of heat of combustion is given in the question. So if we just calculate it, the answer will come 128.02 kilojoule, right? So our question number 10 is done. So let's see question number 11. That is, what is the correct bond energy, single, double and triple bonds between the carbon atoms? Now for this we have to know one thing, that if carbon has 3 bonds here, so what happens, the carbon attracts this one carbon attracts another carbon very much. So if we want to separate it, its energy will be more, and for in case of the second case, that is our double bond is present, so its attraction will be comparably less than triple bond, right? But if we want to separate it, we have to give it so comparably less energy. And for if there is single bond, so we know that it will consume least energy to separate two carbon atoms, so their energy series will be like this, right? So let's see in which option that is given here. That is our option number 4. So for question number 11, option number 4 is correct. So let's see question number 12. Okay, So in question number 12, so they have given us the value of Gibbs free energy of formation, right? Now, so in this question, what we have to do to know a formula, that is del G naught is equal to summation of del G naught of products minus summation of del G naught of reactants. Okay. So for here, we'll write the summation of HI first, that will be multiplied into 2 because it is 2 HI, right? So it will be 2.18, and for this it is given 0. So we'll write 0. That will be a summation of products of del Ng, and here for R, we're gonna write 0 plus 33.8, because you can see that for H2S is given but I2 not given, so we'll write it 0. So if we just calculate it, the value will come minus 30.2 kilojoule. So you can see the del G naught is minus here, so that is the condition for spontaneity. So it will be a spontaneous reaction in forward direction, right? So it is our question number 12 is done. Now see question number 13 here, that is they have given us a graph and told us to fill in the blanks. So uh, here we can see that there is a this transition phases, and there is entropy increases and this temperature. So from this graph we can deduct that this X is here is fusion is happening, right? That is from solid it's becoming what, liquid, and then it becomes vaporization or gas. So it's what is happening here, that is fusion here, solid to liquid. And for Y, it is our vaporization, right? It's from liquid to vapor. Now what is the P here? So it solid is converting to liquid, and that point of temperature is called what? That is our melting point, right? And if liquid is converted into vapor, so what will be that point of temperature is called, that is our boiling point. So our question number 13 is done. Now for question number 14, they have given us the equation, that is X gives us Y plus Z, and absolute entropies are given here, and they have what will be the entropy change in 1 atm. So let's write it. We have to know a formula, that is del S naught is equal to summation of del S naught of products minus summation of del S naught of reactants. So if we just put the values here, that is given, that is 213.8 plus 197.9 minus 120, it is the value given here. So what the value comes, that is 291.7 joule per Kelvin, right? So that's how we deduct this. So question number 14 is done. So let's see question number 15 here. That is what will be the melting point of KCl if enthalpy change for the reaction is 7.25, and entropy changes this. Okay, so let's see it. That is we know a formula that temperature will be enthalpy by entropy. So just put the values here. That is 7.25 joule per mole is given here, and here 0.007, right? So if we just calculate it, the value comes 1035.7 Kelvin, right? So here question number 14 is also done. So let's see question number 16. That is dissolution of ammonium chloride in water is an endothermic reaction, yet it is a spontaneous process. So this is due to the fact. So it is an objective type of question. You have to remember it. The condition, that is del H will be positive for this reaction. Del S is also positive. So here del H is less than T del S. So if these three are here, then only this process will be spontaneous. Okay, so you have to remember it. So let's see question number 17. That is, what will be the signs of del H and del S if NaOH is dissolved in the water? So if NaOH is dissolving in the water, so NaOH first will be solid, then it will be Na plus aqueous, then OH minus also aqueous. So from it's solid into liquid is happening, so randomness also increases, right? Because in solid the atoms are very closely attached, and for in liquid it is loosely attached, comparable to solid. So del S is our positive. Now here if this reaction happens, a heat goes out. So here for the del H it will be minus B because it's exothermic reaction. So that is our signs are done. So question number 17 is done. So let's see question number 18. Is in the reaction P plus Q R plus S, there is no entropy change. So under what condition it will be spontaneous? So you can see that here they said no entropy change. So our del S will be 0. So we know del G equal to del H minus T del S from Gibbs Elson energy equation. So if del S is 0, so it will also come 0 T del S. So del G equal to will be del H. So if this del H is minus B, then is this del G will be minus B. So if the reaction is exothermic, then only it will be spontaneous, right? Because for del H to be minus B, it's exothermic reaction, and this is minus B, then also del G will be minus B. So that will be the criteria for spontaneity. Let's see question number 19. That is, in the equilibrium constant of the reaction is 10 given us, and will be the del G naught at 300 Kelvin. So here we know one formula, that is del G naught equal to minus 2.303 RT log Q. So we just have to put the values here. It is 2.303 into 8.314 into 300 log 10. So what will be the value if we just do it? That will be minus 5.74 kilojoule. Okay, so question number 19 is done. So let's see question number 20. Here it's also an objective type of question, that is at absolute zero temperature the entropy of a pure crystal is 0. So this statement is called what? It is first law of thermodynamics, second law of thermodynamics is called what? So it is our third law of thermodynamics. So remember it very carefully. Okay. So here is our questions are done.